Okay, a complex fraction is basically a fraction in a fraction, and this is not in simplest form, so we need to just eliminate that. And the easiest way to do this is to multiply both the numerator and the denominator by the LCD. So let's figure out what the LCD is again. In the numerator, we have a denominator of x plus 1, and in the denominator, we have a denominator of x. So both of those things need to be in our LCD. So what I'm going to do is multiply the top by x times x plus 1 and the bottom by both of those things. And I'm just multiplying by 1. Okay, nothing is actually changing. I'm just rewriting it. I'm simplifying. Okay, when I multiply 1 by the LCD, it's just the LCD, right? So it's just x times x plus 1. But when I multiply this fraction by x times x plus 1, the x plus 1s are going to cancel, and I'll be subtracting x times x. But notice that the fraction is gone in the numerator. So then we do the same thing to the denominator. I have 2 times the LCD. And then for the fraction, the x's are going to cancel. And we're going to be subtracting x minus 1 times x plus 1. Okay, so let's simplify these. In the numerator, I'm going to distribute that x. In the denominator, I'm going to distribute and then FOIL. That should be 2x squared plus 2x. And then if I FOIL these, this is a sum and difference pattern, so that'll be x squared minus 1. And of course, if I subtract that, I can just make this into plus 1 to make sure that both the x squared and the negative 1 get subtracted. Combine like terms, the numerator, the x squareds are going to cancel, and we're left with just x. In the denominator, we have 2x squared minus x squared plus 2x plus 1. Okay, and then that is much nicer to look at than this original nasty thing that we had. Okay, here's another one. This one, what is happening with this thing? Okay, what we need to do, we have a 1 minus x is like in the ultimate denominator of this thing. So let's go ahead and multiply both the numerator and the denominator by 1 minus x. I'm not actually changing the 1, I'm only multiplying the fraction. I'll throw some parentheses around here, maybe will help. Okay, so in the numerator, I'm just going to have 1 minus x. In the denominator, I have 1 times 1 minus x. And then we have 1 over 1 minus x times 1 minus x, and that's going to cancel. So that's just going to be minus 1. Oops, that's not equals. So let's make sure everything gets subtracted in this numerator. Oh, wait a minute. I still need a common denominator to be able to combine these things. Oh, but let's simplify first, because that is going to clean up actually. So I'm going to leave the 1 alone for a minute. My numerator doesn't simplify, but the denominator does. We have 1 minus 1 down there. So that's going to cancel, and really we just have negative x in the denominator. Okay, so now that that's simplified, I only need this 1 to change into that denominator. So I'm going to make it negative x over itself. And then we can combine these. So this is the numerator is going to be negative x minus 1 plus x if I distribute correctly. And then the denominator is on negative x. These x's are going to cancel, and we have negative 1 over negative x, or just 1 over x. Okay, To solve a rational equation, this is kind of a similar thinking. We're going to multiply both sides of the equation by the LCD. And as long as you're doing it to both sides, you will keep it balanced. So anytime you multiply each side of an equation by an algebraic expression, it's possible to introduce an extraneous solution. So what we need to make sure that we do is check to make sure any of our solutions are not extraneous. So we'll see. Still, we need to choose our LCD first. This, of course, we need an x minus 2. That's what the first guy says. Second guy says, yeah, we do need an x minus 2. We also need an x plus 2. So we're going to multiply both sides of the equation by both of these terms. So on the left, we have 3x minus 2 over x minus 2, and I'm going to multiply by the LCD. On the right, we have 6 over x squared minus 4 plus 1, and I need to make sure both of those get multiplied by the LCD. So this guy gets an x minus 2 times x plus 2, and this guy gets an x minus 2 times x plus 2. Okay, and then cancel what you can. On the left, the x minus 2's cancel. So we have 3x minus 2 times x plus 2. In the middle, both of them cancel, and we just have 6. And on the right, nothing cancels, so we still have the x minus 2 and the x plus 2. All right, do some FOILing. Because it's quadratic, I want to get a 0 on one side. So I'm going to subtract everything that's on the right. I subtract x squared. 6 plus minus 4 is going to be just 2, so I'm going to also subtract 2. And we can factor that. I can factor a 2 out of all 3 of those terms. And two numbers that multiply to be negative 3 are positive 3 and negative 1. Those will add to be positive 2. So that's good. And we have x minus 3 and, I'm sorry, so we have negative 3 and 1 as our solutions to that, as our zeros. So what we want to check those. I want to make sure that they're not extraneous. So just try to plug them both back in. Negative 3 minus 2 is fine. We can plug that in. Think about things we wouldn't want. Okay, I wouldn't want a 2 or a negative 2 in my solution set because those would make the denominator 0. So those would be automatically excluded. And that's an example of something that would be an extraneous. Like you get a 2 for a solution, but you can't even plug it back in. Okay, so that's where that would not work. But these are both okay in our denominators, and so we do not have any extraneous solutions here.